Okay? Yes. So, this is collaboration with my student, Yusuke Asao. Today, just topics is changed to Helicity. My talk is something about topological invariant. I'm coming from the Kyushu University, is the southwest end of Japan. And everybody knows that this vortex ring, there's another vortex ring with previous speakers. And this ring was taken in the laboratory of Kyushu University by Professor Okabe and Inoue. George Batchelor was, I think, charmed by this picture. Then let's start with Helicity. This is so-called topological invariant, and it can, I think, measure the linkage also by including internal structure, rise and twist. Then it is very recent, about just more than 10 years ago, triple knot and more complicated, non-trivial knotted and linked structures was created using the manufactured by the, I think, printer, 3D printer, and ejecting this this non-trivial object. Then let's consider incompressible imbecile Euler flows, and this is governed by so-called Lee-Poisson bracket. Then you may have the question, what is this B? And actually, you can view this B as a functional derivative of the Helicity. Helicity is a Casimir of, this is invariant of Lee-Poisson bracket for arbitrary functional of the Hamiltonian, not necessarily its energy. Then, by rearrange this in this way, then this part is a functional derivative of Helicity. Then Lee-Poisson bracket is written in triple bracket, and you may call this a non-bracket. And non-bracket makes explicit the Lee-Poisson structure. Its origin is Helicity. Then you can understand the structure of the steady or Euler solutions. This is a picture of Weiss, Carnot-Bell, Young, and you may view these are just conceptual pictures, and this line is intersection of energy contour and Helicity contours. Original paper considers only 2D topological invariants. Then you may view this is a normal vector to the energy contour. This normal vector to Helicity contour. And this cross product means orbit of the velocity is just occurs intersection here. Then this picture shows time variation of the solution Euler flow is periodic. Then if this is a critical point on the given Helicity surface, Arnold called this is orthovortical sheets. Then this is a critical point. And actually, you can write arbitrary perturbation resting on the isovortical sheet in this way. This is just a normal of the Helicity contour, and cross product means normal to normal means it's parallel to the Helicity contours. By applying this variation to the kinetic energies, you can easily prove that for the steady flow is this is 0. Then for arbitrary perturbation on the isovortical sheet, energy is just critical. either maximum or minimum. And this is just an idea of the Arnold theorem. Then Helicity is a 3D invariant of 3D Euler flows, and you may know abundance of the topological invariant for 2D arbitrary functional of the vorticity is a topological invariant. If you go to the this Barlow-Klinik include Barlow-Klinik effect, then you may well know alter potential vorticity is a Lagrangian invariant, and this is a Casimir invariant. Then, if you may include a magnetic field, then this is our original helicity, but for the plasma, you have to dress particle momentum with electromagnetic waves. This is MHD. MHD means the charge is zero. Then only this, but the counterpart is magnetic field. And if you forget total inertia, then this canonical helicity becomes a well-known magnetic helicity. And today's topic is more or less about cross helicity. Then let's include Barlow-Klinik effect and Lorentz force together. And both effects destroy original helicity. And you have to find the different topological invariant. Then Nether's theorem helps to find or to identify mathematically. And you may know that topological invariant is an invariant associated with particle relabeling symmetries. What is this? There is abundance of the papers. This is just a few of their lists. And the idea is the following. Consider the map from the Lagrangian level to A to current position Q. Then relabeling means you may change Lagrangian level from A to another A hat using delta A, but current position is unchanged. So you may just tune current position no change, but Lagrangian level change. And then what happens for the variation of actions? This is actions, and you may just postulate variation is no change. This is variational symmetry for the variation of the Lagrangian level with current position unchanged. Then you end up these identities, and you may add divergence because this is zero after integrations. Then this is Euler-Lagrange. First part is Euler-Lagrange equations, and the second part is usually you may discard by using boundary conditions. But Nether uses this part. First, you assume Euler-Lagrange equation is satisfied. Then you are left with divergence of this current, and this current associated with particle relabeling will produce so-called topological invariant. So here, this current is written in terms of the energy momentum tensor in this form, and actually, the time component, zeros component, gives a so-called net charge, and this is a topological invariant. And by just recovering current position. So this is same as the material line, infinitesimal material line element. And you may write this is a D, material line element multiplied by density. So this is governed by the same equation as the magnetic field. And this is integration neutral charge. So this is, you may call cross helicities. This is the same equation as magnetic field, but constraint is Darwin-free, and also this must be compatible with so-called adiabatic principle. This condition is necessary, just current velocity, no change. Then let's go to the relativistic case. And motivation comes from the magnet rotational instability of the accretion disk around black holes when the star or astronomical object about to bomb. Then let's find equation and variation principle to produce it. Yes. So here we may know about the new definition of vorticity. So this is a standard special relativity for coordinates. This is contravariant. This is covariant. Then for velocity, first just defined by the proper time, s. Then this is just realistic component. Gamma is a factor. And enthalpy is a little different from the standard fluid mechanics. It starts with rest mass and internal energy, pressure, and n is not density, n is number density. This is enthalpy per so-called volume, enthalpy per, maybe you may say molecule. And for momentum is defined by not mass, by multiplying this enthalpy, specific enthalpy. Then vorticity in standard relativistic fluid dynamics is just a curl of this enthalpy multiplied velocity. This is in a sense new definition. And if this is dominated, this is coincide with a standard definition of vorticities. And you may find this is energy momentum tensor of the perfect fluid of special relativities. Then if you apply conservation of energy momentum and also you respect first law of thermodynamics, you end up with Euler equations. And previously, my colleague derived or dealt with the topological invariance for the barotropic case, but just let's include baroclinic effect. Then you may, if ion and electrons are separated with plasmas, you have to include this is Faraday tensor, electric field and magnetic field. And you may add, this is just, I think, I forget to write down, this one. Momentum is dressed with electromagnetic momentum. Then this is dressed canonical vortice tensor, dressed with electromagnetic waves. Then conservation of energy momentum gives equations of the plasmas. And MHD is a special case when charge separation is absent and just charge neutrality is established every point. Then for considering MHD, you may take this for electric field is 0. If this is 0, first term equals 0. So this is a limit or assumption of MHD. Then you may just assume, impose these conditions. And you may end up with this MHD energy momentum tensors. Then by applying conservation law of energy and momentum, you have this equation. This is MHD. Then you can apply in the same scheme as a non-relativistic case to the relativistic case, same scheme of the this variation symmetry associated with particle relabeling transformations. Yes, this is a relabeling symmetry of this case, and previously we published about barotropic case. Just include a baroclinic case. This is general scheme, and start from the actions, and also at the beginning you admit Euler-Lagrange equations, and you take a variation of Lagrange level. This is Lagrange level, but in four dimensions. And this is change of the current positions. And later you assume current position no change. This is 0. Then we postulate action is invariant after the change of Lagrange levels. And if you assume Euler-Lagrange equation, this is 0, then you end up with this conservation laws. Therefore, this is Naissa's current. And for special relativity, it is not easy to separate time and the spatial component. Then, relabeling symmetry for the plasma is the following. This is fluid flow map from Lagrangian to the current positions, and for velocity is defined associated with this special Lagrangian levels. And we assume this is no change after particle relabeling, and also this is relation with the specific entropy, and we assume adiabatic. So this is no change. And conservation law of mass, this is you have to just step down to the conservation law of number densities. This is Jacobian. Then for the plasmas, this is action. This is a neutral fluids part, and this is just a charged part. Then take variations. First, you end up with Euler-Lagrange equation as same as before. Then the boundary terms will give use conservation law. Then this is just writing down the change of the positions, and you assume this is 0, and this is 0. Also, if you assume this is 0, then derivative is transformed like this. Also, you assume entropy, current entropy no change, velocity no change, and entropy no change, magnetic field no change. Then relabeling transformation have to constrained by following 4 constraints. This is no change on the current velocity, no change of the, this is I think conservation law of mass. This is conservation law, and current mass no change. Current number density no change. Current entropy no change. Current magnetic field no change. Then it's obvious the action is no change, because the action is just integration of the current position and entropy and number density and velocity and magnetic field. Then you end up with Naissa's current, and this bottom line, this Naissa's current, and this actually you can prove divergence of Naissa's current equals 0. And this is a time component, this is spatial component in Lagrangian coordinates. Yes. So therefore, if you write down the proper time and Lagrange levels, this is conservation laws. And the rest is to Eulerization of these Lagrangian quantities. And you may introduce, like something like vorticity field or magnetic field. And then from this, by multiplying volume element in 3D, and you can reach this formula. And you may just multiply volume element. This is just final form. Multiply volume element of the spatial component of the Lagrangian level space. Then you end up with this. And this is simply written in the form, and you reach conservation law of the canonical relativistic cross helicity. Just make summary. Yes, you derive this from the Euler-Lagrange equations, and but actually this is non-relativistic case. For relativistic case, this volume transformation is 4D. Then you need a bit of work to reach to Eulerian form. Then you just gained this conservation law of relatively helicity. And this is usually you may include charged particles. And if you just impose MHD limit, then charge becomes 0. Then you may take, this is a momentum. This is now previously just any field, very similar to the magnetic field. But for the MHD, you may take this magnetic field. So this is a cross helicity in special relativities. And just one more slide. Actually, we have not reached the final result, but motivation comes from the observations. First, if you choose this any field behave like magnetic field as a special case, you may recover the relativistic arterial invariant. And the dimension of this arterial invariant is same as entropy. It was very recently, I think, introduced by these three Japanese: charge conservation, entropy, current, and gravitation in the context of general relativities. And I wonder whether this arterial invariant is same as cosmological entropies. And this is the original motivation. And now our work is going toward this direction. And I want to know whether this is same or not with Wittgenstein-Hawking entropy or black hole entropy or not. Thank you very much for your attention.